The tuning protocol procedure begins with a teacher presenting an exemplar to a group of faculty members. The presenter will provide the faculty members with the objective, the materials, and the standards the exemplar will meet. The exemplar will also be passed around to the faculty members so they may get a closer look and ask clarifying questions, which the presenter is allowed to respond to. Once all clarifying questions have been answered, then the faculty members will provide the presenter with warm and cool feedback. However, at this time, the presenter is not allowed to respond, but is to reflect on what they are saying. Once the warm and cool feedback has been stated, the presenter is allowed to respond to one or two of the warm and cool feedback and change or enhance their exemplar if necessary.
Well, welcome to Exploding Milk. Today I will be showcasing how milk explodes by using certain liquids. Here we have liquid soap. You can use any type of liquid soap. This is Dawn soap. We have milk. We have low-fat milk. Yours truly. Hope. We have vinegar. And we have baking soda and variety of food coloring. So today we're going to see the reaction with the baking soda and with the vinegar. Will the milk rise, or will it just stay flat with the different materials that we have here? So first I will pour in my milk. On the event, the kids will use a glass, but today I just want to show with the low-fat milk in our bowl here, just to give it more of a display versus just a small cup that I will have for the kids. So here I will pour in. Here we just have regular low-fat. You can use regular whole milk, but we want to see the difference. And yes, I did. We will use different liquid to see will it rise. But here with the different type of milk, you have organic milk.
You keep going though.
Oh, we have organic milk, we have whole milk, we have low fat, but today I'm using low fat milk just for the sake of time. So here I will pour in my liquid soap. And the reason why I'm pouring in liquid soap because we want to see the reaction, the color of our food coloring. Because when you add it in, it just stays in one position. But as the kids will use they'll use a toothpick or a popsicle stick, and they will just move it around. So here they'll be able to see the reaction. If you notice, with the low-fat milk, it really doesn't stick, but with the whole milk, it holds. So here we move it, but now it's just, okay, just a move. But now we want to see, with our reaction of with our vinegar and baking soda, will it rise or will it stay flat? So we pour it around. We will have a measuring cup for our kids. It's not coming out, sorry. So now, you want to pour it in. So then we just wait, and we want to see will it rise. And then here, if we look, and then the kids will also have fun by adding another color, just to give it that more of a swirl. We just put it in and see what happens. And also you could talk about how two colors combine. The primary colors, and we just move it. Just move it around with the soap. But here it did rise, but in our cup it would give it more of a height. But inside here, just see the color reaction. See how it turned.
To eat that.
I wouldn't advise you to eat it. And that's the end of our experiment.
All right, very good. Clarifying questions. You can respond to those questions, but clarifying questions.
I'm sorry, I forgot napkins. And I don't want to get on the table because I know this is food. I'm listening, I just want to understand.
Will the students have a recording sheet to enter their data?
You can have a recorder sheet, yes. Sister?
What's causing the reaction? What's causing the rising?
The baking soda with the vinegar. The baking soda.
Okay, so the reaction between those
The
two.
two. Mm-hmm.
Okay.
Any questions?
Will student work in pairs or groups or individually?
I would say they will do it individually because we will have enough of the supplies that will go around because it will be smaller cups. So they'll be able to see more of the height versus in this bowl here, just to show it to you all. Mm-hmm. So we have small cups and it will give more of a height. And they will have toothpicks.
Good. We saw the product. Now we're going to go ahead and think about some warm and cool feedback. Okay? So warm feedback being the things that you saw that you really liked. Be very descriptive, be very, very, intentional. And also we'll do cool feedback. Ms. Moore will kind of sit there and pause and consider the answers, don't respond to it until afterwards. Okay? Warm feedback.
I like how it's very hands-on, so it can range from not just being younger children, but it can range to our middle school students as well. It's something that the kindergartners could do, but it's also something that a middle school student could come in and do and get the same effect from it. They can understand it.
Okay, good.
I was gonna say the same thing, it's very hands-on, I think it gives them kind of like that, I'm a scientist kind of, I'm a chemist feeling, I'm mixing different things, so that's really, I think that'll be really fun for them.
Absolutely. Cool feedback.
Have you considered really giving your participants background knowledge about acids and base so that they'll really understand and know why the reactions are happening?
Have you considered, using different milks and
Yeah.
compare and contrast, maybe using a thinking map also?
Okay, yeah.
Okay, any more cool feedback? Okay. Ms. Moore, you can go respond to either the warm or cool feedback.
I like all of it. It was a great idea. I would have the data sheet, and also explain. Hopefully, I will have a crowd to be able to explain. People coming in, so it'd be like a group of people that would be there, and I would have like an anchor chart, so they will be able to see the difference, and just a small recording sheet, like a Post-it note, so it would be right there next to the cup, and they would have measuring, so they would have a different. I will of course have like a jug of milk, the whole milk, and we'll use like a little Dixie cup. So they'll be able to see the difference in the small because, depending on how many people come, we'll have a plethora of items for them to use. But yeah, that's a great idea.
Cool. All right.
Thank you.
So the title of mine is called Ice Cold Warmers. All right, so my students, and I've kind of already made it, it's a little messy, but just kind of quickly going over materials. We'll have calcium chlorine ice pellets as well as ice melt. And they do have a couple things that are different than the calcium chlorine ones, as well as just kind of the basic ice melt. All right, it's kind of lost some of its steam, but we'll be using Ziploc bags and water will be basically the top tips. They will shake these up, they'll put the calcium chlorine in these, and once they grab these will become an ice pack. And it's slightly, and can I pass around now? Wait a second, okay. You can still kind of feel the coolness to it. It kind of died out throughout, kind of throughout the day, if you will, and transport. And here, we'll be using, that's with ice melt. With this one, which is the ice pellets, this is supposed to create the hand warmer sensation. Okay, now like I said, this one died out a lot. That's the kind of the negative to it. So I know I'm going to have to kind of measure it to get a good, approximation on how much to put inside of it for it so it can hold it a little bit longer. But like I said, this one is almost as cool as that one by now, but they do have two different chemicals to them. And that's pretty much the sum of the overall Hold'em project.
Excellent job. Okay, let's have some clarifying questions.
What are you gonna do to, I guess, like get the ball rolling? Because I know for me, I understand what you're doing, but to like not dumb it down, but to make it more kid friendly as far as them understanding the concept of what calcium chloride and all of those things are.
Yeah, well, just to kind of take the quote-unquote big words off of it, basically it's just going to be two types of ice melt and how household items have other, what's the word I'm looking for? Have other purposes and uses.
Okay.
And just kind of going from there. And I have my little, I'm going to jazz it up a little bit, but just for time-wise, I can't in here, but yes.
Are you going to compare the items to actual the hand warmers that you
Yes, I actually have those as well where I'll be shaking with, I doubt I'll be able to kind of gauge it off of the thermometer, but just so they can just get a basis of how cold and how cold and how warm the hand warmer as well as an ice pack, one of those travel ice packs.
So is there a number of, I guess, amount that you put in for each bag as far as liquid as well as the materials?
Yeah, that's kind of the part I'm playing with, the ratio, because by them being two different chemicals, I can't put the same in, so I'm kind of playing with it. So the warm will stay warmer because I didn't pass the cold one, I'm sorry, to this side. But the cold one is still staying relatively cold, and it's been about 35, maybe 40 minutes. I did it almost right after lunch. So it's staying for a while, but just trying to find the right combination of the blended water to chemical ratio where to hold. Yes.
Have you considered using various name brands of plastic bags? Would that make a difference?
On that aspect, I'm not 100% sure because it's still, I have to have a Ziploc bag. So that I'm not 100% sure on, so I can't even go into that one just as long as it's sealed. That's kind of where I was. That's a good question.
Oh, yeah, or maybe consider using different temperatures of water.
Temperature, and I played with that one too,
Yeah.
but yes. That's
Okay.
Have you considered explaining similarly to the other one, like chemically what causes that to happen?
Yes, because I'm gonna have to kind of myself as well do a little bit more research on that as well, so I can break that down to them, so it's just not a project and then you're out type of thing. I do want them to understand what it is from that. So that's something that I'm still in the process of really fine tuning where I can break it down to the children. Yes.
Good. Okay, we've touched most of the products. So let's now go ahead and look at warm and cool feedback. I guess literally warm and cool feedback of your products. So warm feedback.
I like the fact that it's hands-on again, but I also like that you're able to give, this is the activity that you can kind of tell the students, here are all the supplies you need. Now you kind of come up with what you think is going to happen. Like this is, especially when you say you want to give them a base of this is what an ice pack would feel like, this is what the warmer would feel like. Now you go and try to replicate. It really makes them into the scientists.
I like the idea that the kids are able to make it just in case if they need an ice form. They're able to put forth this material and really use it for more of a home base.
It's real
And they
world.
could try it, yeah, it's really appropriate for them, so they're able to use it since we're in the cold season.
That's how I'm gonna lead out to like that.
The mittens.
So cold. But don't worry about it. You got to come here and see.
I like how it explains day-to-day things that we use. There's so many things that we use every day, but we don't know how it works. So I think it's really nice that there's like a real life connection. Like, so now I know how this thing actually does this. So I think that's really cool. I think they'll really see more importance of it because they use it.
All right, good. Cool feedback.
That's not bad.
Have you considered not necessarily like explaining the chemicals that you're using and what they can do, and then only providing them with the procedure since you are working with older grades, so that it kind of goes more cross-curricular in different subjects where they have to measure out certain materials and then analyze the data themselves to find out what happens?
Sorry.
Good. Have you considered having each item already set aside as far as how much they need to utilize?
Have you also considered having the students compare and contrast the amount of materials that they use to create the warmth as well as the cold? Do you have to use more or less of one or the other substance?
Have you considered the time fraction, like how long would it stay warm, or how long would it stay cold,
Good.
or if they immediately hit the air, when it gets cold? This, the different temperature versus in the room and outside.
Yeah, just kind of, I guess I'm gonna combine all those. Like I said, one of the big things I am really gonna have to really keep playing with is the ratio of per salt mix, if you will, for each bag. Because like I said, there was a difference. Like I know I put a little bit more in the cold one, and it did hold a little bit longer. So that I do know. But like I said, just kind of coming with the perfect ratio, if you will be kind of the biggest thing. Because like I said, you can feel that one, and it's been about an hour, and that one's still holding. So I know that's the big thing I know I have to work on is the exact an approximate amount about how much I can put in each bag. So that will help with the measurement aspect for the older as well as the younger. So.
All right. Good job, Mr. Johnson.
Okay, so mine is Oobleck, the non-Newtonium liquid. So I'll read different, it's from the book by Dr. Seuss, so I read different sections of it. He goes through different things that are solids and liquids and gases, but this is none of them. It has aspects of them though. And so they use, they make it using cornstarch and water. And in the book it's green, but they could use different ones, different colors, use food coloring. And then once you have it, I would have them put different objects in it. If you go really slowly, it's like a solid, like that. And then the other ones, it goes straight into it and moving it. So to have them make it, it's easier to make it into like a big tub first because they have to use their hands. But then from there, have them in like the smaller Dixie cups so they can do it on their own with different objects. And I would have them, when we go through, going over the definitions of solids and liquids and gases and seeing what they have in common with this and what they don't.
All right. Good. Clarifying
Do
question.
you want me to pass it around? You might not want to touch it with your
I was
hands.
about to say that.
You might get it on your clothes.
What were all of the materials that you used again to
It's-
create the?
It's just cornstarch, water, and food coloring.
This is fun.
I have some parental some service objects.
So when you say food coloring, so they're able to use a variety of color to get a different color instead of green?
Mm-hmm. They can use any different color food coloring. I just use green because it's green in the book.
It will automatically get that reaction of the hardness once they do it.
Yeah, the food coloring doesn't have any effect chemically on it. It just changes the color.
I think it's great that you have a book to share with them as well.
Any more clarifying questions?
And you said they're gonna make a big tub together and then divide it up?
Like that size. It's
Okay.
easier because you have to use your hands a lot with it to
Okay.
get their little hands in something big and then divide it up on their own. So they can do the different part on their own
Okay.
and then take some with them.
So by putting the objects inside, what will it do? By putting different things inside, what will they do with that?
So depending on how hard you put them in there, it either acts like a liquid or acts like a solid. And experimenting to see if it has anything to do with weight or speed.
So if you were to put water in it, it becomes more liquidy, and then if you put something solid in it, it actually it resists, or?
No, I'm talking about like an object. When you make it, it's like 2 parts cornstarch, 1 part water to make that non-Newtonium liquid. When you put different objects in it, it either acts like a liquid or a solid, depending on how hard, but that would be for them to figure out based on it. Based on if they were doing it hard, if it was like a heavy object, if it sinks down in faster.
All right, cool. Warm feedback.
I definitely like how you've taken the properties of matter and everything to show them that there are some substances that can have more than one property or be more than one particular state, because that's always cool for them to see. That there are some things that can be a solid and a liquid.
That's one of my favorite projects. But it's just kind of cool because, I'm doing a similar project, but just the aspect of having a Dr. Seuss book kind of just takes it over the top, makes it very, just cross-curricular. That's just fun, But yeah, that's always, I don't like talking about that one too much, it's too fun.
I echo the others. I love the book.
Yeah, that book is cool.
Okay, cool feedback.
Have you thought about having them be able to compare it to something else that's not a liquid or that can't, I guess, be interchangeable? Like maybe using, instead of cornstarch, using like flour or something. I mean, we kind of know what it'll do, but having them explore, you know, why does cornstarch do this as opposed to something else?
Or just to make it more of an experiment, have you considered giving them the objects that they need to compare in the cups? And so like you could say like, I'm comparing the bottle cap with the eraser to see like which one, is it a liquid or a solid, and kind of like write the data down.
Okay. My project will be on how liquid impacts the magnet. Like on a cooking show. So everyone's gonna have 1 cup, well, half a cup of each liquid. This is water. Half a cup of light corn syrup. Everything will be measured. This is vegetable oil. These are the 3 liquids. We're gonna first add 3 paper clips into each liquid. And with I want students to understand like
Keep going.
how quickly the paper clips move down, and you can see that with the corn syrup, it's still at the top. So I would take a spoon, of course.
Yep.
And kind of push it down so it hits the bottom. So from there, what we're going to do is use our magnet. We're going to see which liquid we'll be able to pull the magnet all the way up to the top. Oh, water did that quite quickly. Let's see about the corn syrup. Well, that's a little bit of resistance. Let's see about the vegetable oil. Came up. So I want students to really just observe and distinguish the differences on what liquids impact, like how much a magnet will be able to move. And that's pretty much it.
Clarifying question.
Oh, can I?
Go
I have one more thing. Before I do that, I want the students to understand the properties of magnets and what magnets tend to attract, and what can what can interfere with magnets attracting one another.
I have a question.
Yeah.
So is the question about how the density of the liquid affects the magnetism, or is it more about the composition of the liquid?
It's more the density. Like this, it's more loose particles or loose molecules.
Okay.
So it's quicker to attract. Whereas this is the liquid. I guess the molecules it is a denser.
What grade levels are going to be in?
I put 2 to 4, but it can definitely be higher or lower. It's a simple project.
Are those the only liquids that you're going to use for the experiment?
I can definitely use more. I was thinking about doing dishwashing liquid. I think that could be a good one to try to. Milk or soda.
Any questions? Okay, if you want to pass it around, you can.
Pass
And-
them around?
Yeah, and while she's passing around, if you guys want to think about some woman cool feedback, we can kind of think about that as well.
Also, I can't talk. Also, I wanted to say, there may be too many variables, but how strong the magnet could be, like if we add 2 or more, would that impact how quickly the paper clip moves to the top?
Have you considered like different items, like each of them have different magnetic items inside versus paperclip, or like a magnet from off the wall, different types of magnets, so you can see the reaction because, different high pulls.
So another, have you considered maybe even like a larger, maybe like a real large, even like graduated cylinder, where you could just kind of even time how long it takes from you get from the bottom to the top, and something, larger than the, 8-10 ounce cup or whatever.
Okay. So now some warm feedback. Warm feedback.
I like that this is different. I don't think
Yes.
many of them have done any, I hadn't seen this before, done anything like this before. It might be very fresh coming to them and really don't know what it would do.
I really appreciate the freshness and everything. That's something completely outside the box, especially with magnet and magnetism. You can actually feel the pull through the cup and things like that. Kudos.
This means I agree. That's what we do in our class.
I just have one more. Just have you considered having one of the cup have all the ingredients in there?
I'll write that down.
Any more warm feedback? Cool
Mom's the
feedback.
same.
Sorry, I was
I've never seen it
Come in,
before,
cool
so it was like
feedback.
exciting. Yeah.
It wasn't cool. It was I like things.
That's cool feedback though.
If you try. I want to try.
Okay, cool feedback. Another cool
Tell
feedback.
that was real quick.
Have you considered giving the students cups where some get the same amount of liquid in each cup and then some get varying amounts of liquid in each cup to depend on if that makes it move faster or slower?
You consider utilizing a thinking map like cause and effect, so they kind of just take notes as well. There's a writing portion for their product as well.
Have you considered using different materials for the cups, like maybe glass or styrofoam?
Styrofoam.
I know.
Have you considered a group project or would this be individual?
I wanted to,
Any more clarifying or any more cool feedback? Okay, Ms. South, you can respond to those feedback.
I like the idea. What did you say?
Different,
This is why I'm like, do I write notes for it?
different material cups,
Oh, yeah.
The styrofoam.
like a glass.
Styrofoam, we can do that. I also like students needing to like make a prediction, like what do you think will happen? Like, share your hypothesis to class with our session.
All right, thank you, Ms. South. Bring it. All right, who's next?
Okay, the project is balloon rockets. All right. Don't do that. Okay, balloon rockets. And what we know to fly, you need lift, drag, thrust, and weight. So we're looking at thrust in this particular demonstration. And so what we're going to do is we're going to create a little balloon rocket. And a couple of questions. How far can you make your rocket fly? That is the first question we'll be dealing with. So we're going to use a balloon, a straw, some tape, and in this case, yarn and a magnet, yes, and a lovely tall rod. Okay, so what we're going to do, we're going to have our balloon here. Blow it up, not to the point of lightheadedness. Okay. So we're going to skillfully, I may have assist one another. Straw here. Another lovely assistant, please.
So I'm guessing
We're gonna
this
have to partner
group
up.
activity.
I want to partner up so everybody will have a chance to have their own rocket. So, thank you, doll. Thank you. And no, we're not finished. You can hold that. All right. Then we're going to take our tape. Oh. We're going to tape our balloon to the straw. If you could hold it nice and tall, as though that is anchored on the wall. Uh-oh. No injuries, please.
You got FMLA on you.
Okay. Do we have any predictions? Do we have any predictions?
I predict it's gonna go far.
I don't think it's gonna make it to the.
What's, you don't think it's gonna make it to the top?
No.
All right, let's see. On your mark, get set, lift off.
Whoa! How cool is that?
It would've kept going.
So, one question that I added, and may add some more, but, will this same balloon fly as far if I use it a second time? What do you think?
I don't. Think
You don't
it
think?
goes far.
Okay, thrust is a pushing force created by energy. So, you think we'll have as much energy the second time as we did the first time?
I think so.
Let's try it out.
Oh, wait,
Vanna?
We need you.
I didn't wanna.
Vanna?
We don't need to 4 o'clock, go ahead.
All right. Okay.
I don't even imagine.
Oh, Lord, be careful. Where's your tape? Hell freezes up. All right, Amar, get set. This off.
Oh.
We're back to the second time, huh?
You tried to do it
Okay.
wrong, huh, didn't you?
All right. Try. All right. That's it.
That's cool.
And we'll do, I'll race them in pairs, so kind of everybody have their kind
A
of,
relay.
yeah, yes,
I was
yes.
about to say, if you need some help hanging anything, I got you.
All right, we're holding.
No, I'm not gonna hold it. I think so. I might be busy that night.
Right.
Clarifying questions. Very good.
One question I had is, as you were blowing the balloon up the second time, like the size of the balloon may be different, so it may
Yes.
be a little bit smaller, maybe a little bit bigger, and that could impact how fast or how far it may move.
So do you have any suggestions as to?
Oh, my question.
Oh, I'm sorry.
My question would be, do you think the size of the balloon impacts the speed of how it got?
That's another question that was a part of the experiment. So
Okay.
I may actually do that, actually even use a larger balloon and then a smaller balloon as well and add that as a variable as well.
Or, I mean, I guess like how much, like how would you measure how much air you're putting out? You know what I mean? Like,
This, okay, so like maybe we can make a visual control, like maybe put 2 lines on the wall, put 2 lines of tape. Okay, does your balloon match?
I would say I have a
So that'll be.
suggestion for that. I wouldn't say even if you just kind of give them off 10 seconds and blow as much where, it kind of, that's going to be more of a kind of a balance across the board, I would feel. Like, all right, you have 10 seconds.
But some people may not have as much wind.
You were,
10 seconds, somebody was like, boom,
So you'll be able to see
And
it.
as
then
much
you
with
will
that.
see.
Do you be able to see the
That's
Well, I
what
noticed
I'm
like with the yarn, will the yarn be going up like a hill, or will they completely go across like horizontal?
No, it's gonna go up.
It's gonna go up, so
Go
how
up
would
to
the
the
children
top
get up
floor.
there? Would they, oh, so you already have them
Yes,
up
I'm
there?
gonna anchor it up.
Okay.
Yeah, I'm gonna anchor it with something stronger than this, but today what I've been using is
Staple them, man.
the board. Yeah, staple
Staple
it.
them, man.
Yeah,
Have
we
you
do
tried
anchored
like different
strands.
lengths, have you tried different lengths?
No,
From going across from the room,
no, but I think I
from out in the
should.
think that would be
hallway,
kinda
inside the
cool,
classroom?
Oh, all right.
Like from that pillar to your room, to show the difference,
Yeah.
take it outside the classroom.
That's cool.
Oh, yeah. Okay, I like that.
Good. All right, warm feedback.
I like that this is really active.
Yeah.
It's like more than hands-on, it's very active.
I like that it's very brave. I think you're gonna have a lot of like screaming and yelling and really a lot of excitement. So like, yeah, I think it's.
I think this is like really a good Y chromosome activity. Yeah. So it's really gonna be captivating for them, especially the boys.
Gotcha.
Okay. Sorry. My bad.
I like how you're able to incorporate like speed, time, velocity, like all those things can be taught.
It's true.
Cool feedback.
Have you considered having the students get like a measuring tape and measure the size of their balloon as they do it? Like maybe the first one, it was, I'm just throwing numbers out here, 5 circumference or whatever, and then, around and do it based on different sizes, because they could compare it to like the different sizes of like airplanes, a jetliner.
Oh, yeah, we
This
need more
much
thrust
thrust,
and,
as opposed to like a
yeah.
single engine plane, a prop plane, something like that.
Yes.
Have you considered time stoppers? Oh, I'm sorry. Clock stopwatches.
Yeah.
So when they do it, if you're doing like in groups, they'll be able to measure who gets up there, like, is it 0.5 seconds, 0.3 seconds? How long does it take my balloon to reach, depending on the distance?
I was,
I can't answer right now. I'll see how to take notes. Mine is very similar. Have you considered students predicting the distance of their rocket based on the size of their balloon? And then, like you were even saying, measure and compare, like an airplane goes so many miles per minute and things like that. And are they breaking those barriers or what have you? And how far is their rocket going? Or even how fast a rocket reaches the atmosphere to outer space and stuff.
I'll say even have you considered even with possibly bringing in maybe a balloon that has helium in it and kind of compare it amongst human hot breath, if you will.
Have you also considered having the balloons already pre-blown up so that they were, and then that way, when they are ready, they can just be carefully clip the end? And then in that case, if they're pre-made, have you considered having them be allowed to add fins or anything to see if they have like you've X amount of time to make your shape more aerodynamic to see if it'll make it go farther to have more of a contest?
Ooh, and even like with the air pump as well. Yeah, you said even it's stated for the ones that cannot blow due to even like getting the air pump, where you know what I'm saying, boom, boom, and it'll pump it up. So you don't have to blow it. So then, like I said, then that's just another variable amongst,
Yeah, because they gotta re-blow it up.
That's fine. You know, like that.
you blow it first time, let me blow it second time.
That was right.
All right, Ms. Caldwell, you can go and answer some of the clarify or some of the cool feedback.
Yes, I like the idea of measuring the balloons and really, demonstrating how a larger body would need, more thrust. It's more weight, really, would need more thrust. The different sizes. Helium, I think that would become kind of a logistical thing, making it a little bit more difficult. And I was thinking about, the pre-blown thing, like how would we manage it not being sealed and clipping the ends off? Are we gonna be busting and stuff like that? But I'll explore, definitely explore those options though.
That's fun.
All right.
So mine is called Humpty Dumpty Had a Great Fall. And I'm gonna have my students, I would like to work with grades 4 through 6, and I'm gonna have them be working in groups of 4. They're gonna get, each group, I'm gonna have them pre-made, is gonna get the same amount of materials and the same size of each material. And they can be as creative. I don't think I'm gonna give them an example. There is a video that I have that we're gonna watch, but I want them to use their own creativity. I was trying to incorporate creativity and perseverance with this project and working as a group. They'll have 10 minutes to talk about how they want to use the materials first and have a way to draw a diagram. And ultimately they're going to try to create a structure that they think is going to protect their egg from being cracked. So I have my egg in here. And once the time, they'll have 20 minutes to construct it, and then we'll be taking it outside into the stairwell by the first door, and we're going to drop it from 3 different heights. So the first height will be 3 steps up from the bottom step. If your egg has not been cracked, you'll get to go to the next step, which is the first platform on the level. If you pass that, you get to go to the very top, and we'll be dropping it from the top of the steps. And if your egg chute has protected your egg on all 3 levels, I will reward you with a nice little prize. But they'll each get, obviously, like I said, the same amount of materials I used. I don't know what this is called. I said wire, but
Chenille stem.
yeah. A plastic bag. I'm thinking bigger because I had a hard time with it. String, a cardboard box, and some tissue. I wanted to be really limited in the resources, so they had to be more creative with it. And I did drop mine already, so hopefully it'll work again. But I'll obviously we'll take turns dropping it with each other.
Sit in that chair.
Come on. I'm excited.
Okay. So they'll stand up. The partner can take turns with how they want to be held.
to drop it so that it falls properly, and then we will release it. And hopefully mine's okay. It was okay earlier when I did it with that Humpty.
He made it.
Yeah.
He made it.
He's alive! So then I get to go to the next step, and we'll continue. For the students that don't get to, I might let them try to rethink their design, and we'll mark the crack on their egg so that they can go to the next step, so that we know that was the original, and they can try again.
All right, clarifying questions.
Are all the eggs gonna be hard boiled?
Yes.
Yeah.
This one is.
I know that's I was like, who's gonna clean all
Yes, they will be.
So they all will have the same container, the same.
I made my container.
Okay.
You know,
Okay.
they all will have like the same size cardboard.
Oh, so it's got, okay, gotcha,
Yeah.
gotcha.
So what is the total time in making it and designing it?
They will have a total of 30 minutes from the conversation to the construction. I might extend that to 45 minutes, is what I said. I think you will need it, but for me to get 2 sessions in and test, I'm a little concerned about that. So, with the amount of students.
So what are they testing?
They're testing to see if their structure is capable of protecting the egg from cracking from the distances.
I'm sorry, like scientifically, what are they testing? Are they testing like what term or law would it be?
Velocity, gravity.
You're asking.
Yeah.
You're asking that.
Yes, okay.
Yeah. Gravity. Defying gravity.
You want to pass it around for us, Ms. Kuehl?
Yes.
And while she's passed around, we can go and think about any kind of warm or cold feedback.
I like how students have to construct and use teamwork to build.
I tried having Chelsea help me, but she would not help me.
I was eating.
They have to, teamwork makes the dream work, so they have to collaborate and see what works best.
I like how it really gives an opportunity for creativity.
I like how you're able to go in the hallway and do that kind of testing. That's pretty sweet. Because people love that. Parents love it too. All right, cool feedback.
Have you, oh,
Go ahead.
have you considered different Ziploc bags?
Have you considered different types of eggs, like different sizes, or like organic to regular eggs? Maybe it might be a difference.
Have you considered maybe like a grocery bag?
Can I make a comment on what she just said?
You say it.
Okay. I have to say after this.
There you go.
Oh.
So yes, I had a hard time with this bag, so just because of the smallest, I think a gallon size bag or a grocery bag might be better. The only thing, grocery bags sometimes have holes in them. So I was kind of considered, why need those holes? So, yeah. But yes, I've considered the bags and different eggs. I would like to see, but I think that's changing a variable, but I will consider it.
Have you considered, oh, is that all right, meaning?
That all right.
Okay, so I'll do it.
For a time frame, Ms. Taylor, ready to go?
Yes.
All right.
My project is called, it's called Color Symphony, and basically what students will be doing is, it's kind of similar to what Ms. Moreland did, but we'll be doing something totally different. As far as students will be getting milk, and they have to put the milk on a cookie sheet or on, well, we'll be using pans, cookie sheets, and then they're dropping different colors to see how the colors change as you add different substances to it, such as soap. Because basically what you want to do is see the colors dance. As you add the soap. And so, one thing that I noticed was that when you do the project, it actually tells you to use whole milk as opposed to fat-free milk. So what me and Ms. Bella had decided that we were going to do is that we were going to set up stations almost like, because they're working a group of 4, we'll set up stations where they have to come get a bag, and in each bag they'll have the same supplies, but they'll have different name brand products. So somebody might get fat-free milk with dollar store dish liquid, as opposed to somebody getting Dawn with whole milk, and then somebody getting organic milk, just to see what's going to happen based on what's the reaction going to be, and based on ingredients, like how many active ingredients is in the soap that's considered name brand, as opposed to how many active ingredients is in the soap that's considered from the dollar store, stuff like that. So that's the basis of the project.
All right. Clarifying questions?
Will each student have the same size pan?
No,
Or-
they'll have different sizes,
Different
just to see, does it move faster if it's in a small amount, does it move faster if it's in a big amount, but they will all have, the same amount of each, of liquids. They'll have the same amount of liquids.
How long do you think this will take, the project?
I don't think the actual project will take long. I think what's gonna take them longer is filling out, what do they think is gonna happen, because they're gonna do like, what I think is gonna happen prior to doing the project, doing a hypothesis, and then filling out like the little data sheet after they've done it. And then us just going, and then us just going over like what is an active ingredient, those prior steps to, before we throw them into project action.
What grade children did you say this was for?
Mine was, at first I thought I could do the younger kids, but we're gonna actually do 3rd to 6th.
All right, warm feedback?
Have you considered, have you ever,
Warm
warm, sorry, warm, my bad, I'm sorry.
It's pretty fun.
I like how visual it is for
Yeah,
kids who are
yeah.
visual learners to ask questions, why did they actually move away from the soap?
I like that it's hands-on. They're like making it do that. They can make it move.
Okay. Cool feedback?
Maybe scratch
There you go.
I know, right? Have you tried water? Just to see the difference versus versus from milk? Like what would happen like if you put the pan of water in there?
Well, they used to be different substances. Period.
Have you even, maybe even if you put, kind of reverse the order, if you will, if you have the soap, kind of like framing whatever the pan or what is, maybe with the soap around, how does it act then? Flip the order maybe.
Taylor?
I actually didn't think about reversing the order of ingredients, only because I'm so used to trying to get my kids to follow the steps. But I think that would be a good thing, because I could have one team do it in a total reverse, because basically in their bag we could put, this is your steps, and we could put it out of order to see what's gonna happen, and then let them share out, what happened, and then the other students will probably notice that's not the step that we use. So that's a good idea. And then I didn't think about trying, I thought about trying different types of milk, but I didn't think about trying other substances to see what's gonna happen.